about 1.5 seconds, so that'd be 1.5, comma, a maximum height of 36 feet, comma 36. So there's the coordinates for our maximum for our vertex. Now, let's go ahead and go to point B. What does the vertex represent? Well, this is the maximum height of the golf ball, right here. Question C, when does the golf ball hit the ground? Well, it begins down here on the ground, but it hits the ground back over here at 3 seconds, when t equals 3 or at 3 seconds. When is f of t equal to 32? That means when is the height equal to 32 feet? 32 feet right here occurs in 2 different times, because remember the golf ball goes up and at some point hits 32 feet and also hits 32 feet in height on the way back down. Those 2 times are at 1 and 2 seconds respectively. For question E, find the height when f is 1. So when time is equal to 1 second, what's the height? Once again, 32 feet. Find the height, basically, in 2 seconds. At 2 seconds, once again, the height is 32. So that's just reaffirming what we discovered in point D. Now, what is a reasonable domain? Since this is a real-life scenario, this action does not go infinitely. So the domain is going to be everything from 0, when it first leaves the ground, to 3 seconds, when it stops and hits the ground again. So that's our domain, or our time. From everything from x is everything from 0 to 3. All real numbers from 0 to 3. What is the reasonable range? Well, that would be the height. That'd be everything from 0 up to a maximum height of 36 feet and back down again. Or basically everything between 0 and 36 feet. All real numbers in between, because it hits every height at some point. So there's an example of a real-world application. Now let's go ahead and move on to part 5, and I guess we can do most of that together. There's no graph here and there's really none needed. The following table represents a quadratic function. Find the following. So the vertex. Well, x is my number line. So if I look at it, going from left to right, I'm going from negatives to positives. So let's look to see how my y values or my f of x values are behaving. They're going from 5 to 0 to -3 to negative. So they're going from high to lower, or from positives down to negatives, 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 and they swoop back up again to the positives. So what I have basically is a graph that is kind of doing this thing right here. So I know now I have basically a minimum, a vertex. So what's the minimum value that my y values get to? Well, the minimum height I get to is right here at -4. So my vertex, I can say, according to this graph, is at 1, -4. Without any other information, that's all I know, so that's the lowest point it hits, at -1 for something like over here. The roots, okay, well the roots are whenever my y value is equal to 0. So I'll look, and here's a 0, and here's a 0. So what are those x values that go with it? Well, I have a -3, and I have, again, a 1. So it hits somewhere over here, -3, and this would be like a 1 over here, if I'm just sketching my graph roughly. My y-intercept, well, that would be wherever my x equals to 0. Here's where x is 0, and my y-intercept is here at -3. Now, find when the function value when f is -4. When f is -4, my function value is 5. When my function value is 3, which is over here, when x is 3, my function value then is 12. And then find the x value when I get a result of -4. I get a -4 right here when x is 0. And I should get it again someplace else, I would imagine. Well, no, that's actually, I read that wrong. It's actually be our vertex at -1. I don't know what I was thinking. There you go. Hopefully you guys caught that. So when I get a -4, is that when x is equal to -1. There you go. So good luck with these notes, and feel free to ask your teacher if you have any questions about these, and I will see you later.